You know, it's easy to think of artificial intelligence as just one big single thing. But what if I told you that, just like people, machines have totally different ways of learning? Some of them need a teacher, some are like little explorers, and others learn just by trial and error. So let's break it all down.
Okay, so let's start with a really simple question. If you show an AI thousands of pictures of ocean life, how in the world does it learn to tell a shark from a dolphin? I mean, they look kind of similar, right? Pointy nose, fin on the back. It's a classic problem, and the answer to it really gets to the heart of how AI actually learns.
And trust me, it's not magic, not at all. It's a really carefully designed process. Today, we're going to dive into the 5 fundamental ways machines learn, so you can see exactly what's going on under the hood.
All right, first up is probably the most common and, honestly, the most straightforward method: supervised learning. The best way to think about this one is to just picture a student who has a very, very dedicated tutor.
The secret to supervised learning is right there in the name. It's supervised. This means we feed the machine a gigantic data set where every single piece of data is already labeled with the right answer. We showed a picture and say, that's a shark. We showed another one and say, that's a dolphin. It's basically like giving a student a huge stack of flashcards with all the answers printed right on the back.
So what does a supervised model actually do? Well, it really comes down to 2 main jobs. The first is classification, which is all about sorting things into different buckets. Is this email spam or not spam? Is the animal in this picture a shark, some coral, or maybe seaweed? The second job is regression. Now that's not about sorting, it's about predicting a specific number, like what the price of a house should be or what the temperature is going to be tomorrow.
Let's make this real. Say you want to set a rental price for your vacation home. What you do is gather a bunch of data on other local rentals, their price and how many bedrooms they have. You then plot all that data on a graph and have the model draw a line that best fits all those points. So now you can just find your 3-bedroom house on that line and see exactly what price the model thinks you should charge. Simple, direct, and completely supervised.
So, what happens when there is no answer key? Well, that brings us to our next style: unsupervised learning. This one is our independent explorer. It's like we drop it into brand new territory and just tell it to, well, find something interesting. You'd use this when labeling all your data is just impossible, or maybe when you don't even know what you're looking for yet.
So here's the absolute game changer. The data is unlabeled. There are no right answers given to the machine beforehand. Its entire job is to just sift through all this raw, messy information and find hidden patterns, structures, and relationships all by itself. It's basically looking for things that naturally seem to group together.
And its main jobs are a little different too. The first is clustering, just grouping similar things together. Think of a service like Netflix grouping viewers into different taste clusters without anyone telling it which groups to make. The second big one is anomaly detection, finding the odd one out. And this is incredibly useful for things like spotting a fraudulent credit card transaction or a weird reading from a heart monitor.
Here's a great example of how this works in the real world. Imagine feeding a model tons of unlabeled patient data, biometrics, diet, prescriptions, the whole shebang. The model might crunch through all that and identify, say, 3 distinct groups of patients with similar characteristics. Now, it can't name them, but it can see the patterns. Then, a human expert, like a doctor, can look at those clusters and say, aha, this group has all the markers for a high risk of diabetes. The machine finds the pattern, the human provides the meaning. Okay, so let's just put them side by side for a second. Supervised learning, it uses labeled data to answer a very specific question you give it. Unsupervised learning, on the other hand, uses unlabeled data to discover hidden patterns you didn't even know to ask about. One's a student with an answer key, the other's an explorer in brand new territory.
Supervised learning is super powerful, but labeling all of that data, it takes a massive, massive amount of human effort. So what if you could get the best of both worlds? Well, that's where AI researchers developed some really clever shortcuts: semi-supervised and self-supervised learning.
Semi-supervised learning is pretty much exactly what it sounds like. It's a practical hybrid. You take a giant pile of data, but instead of labeling all of it, you just label a small, manageable chunk. The model then uses that little bit of labeled data to help it make sense of the much, much larger unlabeled data set.
A perfect use case for this is speech recognition. Imagine having millions of hours of audio clips. It would be physically impossible for humans to sit there and transcribe every single one. So instead, you transcribe maybe a few thousand, you feed that to the model, which learns the basic patterns of speech, and then it uses that knowledge to figure out all the rest of the untranscribed audio on its own.
It's a huge time saver.
But what if the model could teach itself entirely, without any human labels at all? Now that's the big idea behind self-supervised learning. Here, the AI cleverly creates its own labels by using one part of the data to predict another part. It essentially makes up its own little quizzes and then checks its own answers. It's pretty brilliant.
I absolutely love this analogy from the source material. The writer says they saw an armadillo just one time, and after that, they could recognize it forever, from any angle, even in a drawing. See, our brains don't need thousands of labeled photos to learn what something is. We get the object's core features. Self-supervised models try to do the exact same thing, learn the underlying structure of the data so they can generalize from just a little bit of information.
And you've definitely used this, probably today. Gmail's Smart Compose is a perfect example. The model was trained on billions of sentences. Its only task is to predict the next word based on the words that came right before it. So the words you've already typed are the input, and the correct next word is the self-generated label. It learns all the patterns of language completely by itself.
Okay, so far, everything we've talked about involves learning from data that's just sitting there. But what if a machine could learn by actively interacting with the world? That brings us to our final style, reinforcement learning. And this one is all about learning from experience, through pure trial and error.
And it's pretty simple, really. Here, the AI, which we call an agent, exists in some kind of environment. It performs an action, and then the environment gives it feedback, either a reward for a good action or a penalty for a bad one. And over millions and millions of trials, it just learns a strategy to get the most rewards possible.
E-commerce sites use this all the time. An app recommends a product to you. That's an action. If you ignore it and just scroll past, the model gets a little penalty, like -1 point. But if you click on it, the model gets a reward, +1 point. Over time, it learns to stop showing you the things you ignore and start showing you more of the things you click on. It's learning your preferences directly from your actions.
All right, let's bring it all home with a quick recap. First, we had supervised learning. That's our guided student, learning from labeled data. Then unsupervised learning, the explorer, finding hidden patterns in unlabeled data. We saw the shortcuts, semi-supervised, which uses a little bit of labeled data to understand a lot of unlabeled data, and self-supervised, which gets really clever and generates its own labels. And finally, reinforcement learning, our player, learning directly from rewards and penalties.
And that brings us to our final thought. As AI just keeps evolving at this dizzying pace, which of these learning styles do you think will shape our future the most? Or maybe it's a new hybrid we haven't even imagined yet. The answer isn't just for a textbook, it's going to define the next generation of technology we all use. Thanks for tuning in.